During World War II, P-47 Thunderbolts were adopted in the role as a fighter bomber. They could attack ground targets with either bombs, rockets, or machine guns. The channel has produced videos covering machine gun, air-to-ground strafing, and HFAR rocket usage. The intent of this video was to review P-47 dive bombing tactics, targets, lessons learned, and combat effectiveness. As a dive bomber, they were used effectively to cut German rail lines, destroy German pillboxes, bridges, armor, and other hardened targets. The advantages of the P-47 when used as a fighter-bomber are listed on this page from a declassified May 1945 document titled A Report on the Combat Operations of the 19th Tactical Air Command. There are three U.S. fighter-bomber aircraft types used in the European theater, the P-47, P-51, and P-38. The P-47 is used almost exclusively as a go-to ground attack fighter bomber. The advantages of the Thunderbolt include its toughness, bomb load carrying capability, ease of maintenance and operation, and ability to take battle damage. The P-51 and P-38's liquid-cooled engines are much more susceptible to battle damage. German light anti-aircraft gunfire is the biggest hazard to the operation of a fighter bomber given its low attack altitude. This is an example of a German light 20mm quad mount AA gun. Each of the P-47's three weapons will have different ballistic characteristics the pilot will need to account for, as discussed on this page from a May 1945 AAF Fighter Gunnery School manual titled Fighter Gunnery Rocket Firing Dive Bombing. Bullets and rockets are more accurate than bombs given their flatter trajectories, but a 500-pound bomb has around 30 times the amount of explosive fill as a 5-inch HFAR rocket. Accuracy is dependent on release range, dive angle, and altitude of release. Dive bombing accuracy increases with lower release range, higher dive angle, and lower release altitude. Optimizing these parameters was a challenge since the P-47 was not equipped with dive brakes or any special bomb sight like planes designed for dive bombing. The P-47 pilot will need to release the bombs at higher altitudes, shallower dive angles, and longer distances than a dive bomber due to the lack of speed controlling dive brakes. P-47s have three bomb pylon attached locations. The pylons have sway braces to help stabilize the bomb. They can be used to mount either droppable fuel tanks or bombs. The P-47 can carry 2,500 pounds of external stores, as defined on this page from a March 1945 tactical planning document. This page outlines the type and size of bombs carried by the P-47s in combat from an Army Air Forces Board document titled The Effectiveness of the Third Phase Tactical Air Operations in the European Theater. 75% of the bomb tonnage dropped were the 500-pound class general-purpose bombs. Around 8% were the larger 1,000-pound GP bombs. 7% were fragmentation, 1% incendiary, and the remaining 9% other. This page shows the various sizes of U.S. World War II bombs. The 500-pound class general-purpose bomb is identified here, and the 1,000-pound class here. Characteristics of the M64 500-pound general-purpose bomb are shown on this table from an August 1944 terminal ballistics data document. The bomb is 59 inches in length, 14 inches in diameter, weighs 512 pounds when filled with 260 pounds of TNT. The bomb's detonation train starts by either the nose or tail fuse, which detonates the boosters, which in turn detonate the bomb's main explosive fill. Most of the bombs were set for instantaneous detonation on contact, but some bombs could be set for a small time delay, depending on the target. This page outlines the thickness of armor a bomb can penetrate depending on the fuse setting. A 500-pound general-purpose bomb set with an instantaneous detonation fuse can penetrate 3 inches of armor. A Panzer VI Tiger tank's turret roof armor is only 1 inch thick, as defined on this page from a 1943 Military Intelligence Service Tactical Trends document. This bomb, or even the 100-pound general-purpose bomb, should be able to destroy the tank with a single top direct hit. A 500-pound general-purpose bomb should be able to perforate through a concrete slab of 1 to 1.5 feet thick, depending on the concrete strength. This chart shows the path and depth of a 500-pound general-purpose bomb in soft soil at the point of detonation, depending on the fuse setting. The bomb will follow this path in soil if dropped from a fighter in a 60-degree dive at a speed of 350 miles an hour at an altitude of 4,000 feet. The bomb has a potential to burrow 18 feet below the surface depending on the fuse time delay value. The crater size based on the general-purpose bomb type and fuse setting is shown on this page from a 1945 document titled The Relative Effectiveness of Various Types of Bombs and Fuses. A 500-pound general-purpose bomb crater size varies to a maximum of 36 feet wide and 9 feet deep for a 0.1 second fuse time delay. This pilot is checking the nose fuse arming wire of the 500-pound general-purpose bomb attached to the P-47's wing station pylon. There were lots of combinations of bombs the P-47's 3 bomb racks can accept, as described on this page from a 1945 document titled A History of the 8th USAAF Fighter Command. The type of bomb varied based on the target. The 1,000-pound general-purpose bombs could be carried for special targets like bridges or hardened pillboxes. The planes handled well with a bomb of this size. The bomb slightly affected the P-47's rate of climb performance. It can be released from the same dive angles as the smaller bombs. The 500-pound bombs do not affect the P-47's rate of climb or maneuverability to any meaningful effect. Since the target of a dive bomb attack may not be known, the planes within the group may carry different bomb loadouts where each loadout was optimized to a specific target. For buildings or fortifications, a general-purpose bomb attack will be followed by a fragmentation or incendiary bomb attack. The purpose of the second attack is to cause casualties of the fleeing personnel. This image shows a typical fragmentation cluster bomb. 2 500-pound general-purpose bombs with instantaneous fuse setting was the most frequent P-47 loadout, as discussed in this 1944 document titled 12,000 Fighter Bomber Sorties. This bomb was well suited for non-reinforced concrete fortifications. An 8 to 11-second time delay was used for cutting rail lines where the bomb would burrow under the track embankment by skip bombing tactics. This bomb, with the longer 6 to 12-hour fuse setting time delay, would be dropped on motorways at night to discourage road usage. This image is an example of rail track cutting damage by a P-47's 500-pound bomb where the bomb burrowed into the embankment and detonated after 8 seconds. The P-47's bomb loadout and dive bombing tactics for attacking bridges are described on this page from a 1944 document titled Offensive Fighter Operations in the TAF. Skip bombing was not effective. Dive bombing with 1,000-pound bombs was found to be the most effective bomb size. The attacking P-47s carried 2 of these bombs. They would start the dive from an altitude of 8,000 feet at a dive angle from 40 to 60 degrees. They would target the shore embankments. 12 P-47s destroyed the Vernon Bridge on the Seine River. 4 P-47s were assigned to dive bomb the north side of the bridge, 4 to the south and 4 to the center. They then dropped 1,000-pound general-purpose delayed fuse bombs in the wreckage. The fuse delay duration was set from 3 hours to 3 days to hamper repair crews. The road traffic that jammed the bridgehead was then strafed. This page from a November 1944 Air Staff intelligence document titled Impact summarizes the bridge destruction effort over the Seine River. The bridges over the river were destroyed by a variety of light bombers, medium bombers, and fighter bombers, including the P-47. Credit was shared between the bombers and fighters. A study of this attack showed dive bombing was 1/3 as accurate as minimum altitude attacks, but less dangerous. Correct fusing is vital for a successful attack. The collapsed Vernon Bridge attack by the 12 P-47s is shaded here. The planes will generally scan for targets at an altitude of around 12,000 feet. When a target is sighted, the squadron will split into a dive bombing attacking force and a top cover force. A fighter bomber squadron is around 16 planes. These P-47s are equipped with a 75-gallon center-mounted drop tanks and wing-mounted 500-pound general-purpose bombs. Same configuration on this P-47 armed as a fighter bomber. Fighter bomber dive bomb attack tactics are outlined on this page from a 1945 AAF evaluation board document titled Tactics and Techniques Developed by the United States Tactical Air Command in the European Theater of Operations. Approach the target at a 90-degree angle from the direction of attack, since you will be rolling towards the target. Start your attack from an altitude between 6 and 10,000 feet. Attack direction is based on many factors such as the type of target, sun, and wind direction. Attack bridges along their direction, while trains at a 90-degree angle from their direction of travel. Attack with a head or tailwind, no crosswind, and sun at your back. Back off on the throttle as you dive as to not overspeed. The angle of dive is between 40 and 60 degrees. No standard bomb release method has been developed, so use pilot best practice. No yawing or rolling the plane at bomb release. The bomb release altitude is between 2,000 and 3,000 feet. Recovery is set at 1,000 feet above the target. The P-47 speed at bomb release will equate to 400 miles per hour as defined in this table. We can graphically represent these P-47 dive bombing parameters on this chart. The wind is in this direction. A diving roll starts at a 6,000-foot altitude. The P-47 releases the bomb at a 60-degree dive angle from a 3,000-foot altitude at a speed of 400 miles per hour and recovers from the dive at an altitude of 1,000 feet. Given these inputs, we can output the bomb striking parameter details using this dive bombing chart. Follow the bomb release speed 400 mile per hour curved line until it intercepts the 60-degree P-47 dive angle here. Draw a horizontal line until it contacts the release altitude time of flight graph. Follow the curved line until it intercepts the 3,000-foot release altitude vertical line. This red circle point is important. Draw a horizontal line back to the first chart and stop at a point where it reaches the vertical of the dive speed dive angle point. The two significant red dots provide the bomb's ballistic strike parameters. From here we can determine the bomb's time of fall is 5 seconds. Its horizontal speed at target strike equates to 300 feet per second, and its vertical speed equates to 720 feet per second. The bomb will strike the top of the Tiger at an angle of 67 degrees from the horizontal at a contact speed of 780 feet per second or 532 miles per hour. The horizontal distance the bomb traveled from release to tank strike is 300 feet per second times the 5-second time of fall, or 1,500 feet. The P-47 will need to release the bomb a distance of 1,500 feet back from the target. So how effective were fighter-bomber attacks? Dive bombers were used to attack pinpoint targets not seen by medium or heavy bombers. As discussed in this 1945 U.S. Tactical Air Power in Europe document, strafing attacks usually followed the dive bombing attacks. This tactic was very effective in disrupting rolling stocks. This image shows a P-47 which bombed a rail line but was caught in the bomb's burst and crashed. This graph shows the weight of bombs and category of targets fighter bombers attacked by the 9th Air Force from June through December 1944. This includes troops, armor, MC concentration, bridges, rail cutting, and other targets of opportunity. This page describes a tactic P-47s adopted in disrupting German rail. A group of P-47s would follow a rail line, dropping a single 500-pound bomb every half mile along the track. A 35-mile length of track was cut in 70 locations. They would return the next day and strafe the repair crews. This image shows the level of destruction 500-pound general-purpose bombs dropped by dive bombers can cause along a rail line. The 3 bomb strikes are flagged. If properly delayed fused, these craters should be 36 feet across and 9 feet deep. This page lists the fighter-bomber claims during the Battle of the Bulge from December 16, 1944 to January 16, 1945. This includes 751 tanks and armored vehicles, 6,037 motor transports, 18 bridges, and 654 rail line cuts. This page outlines a case where the threat of a dive bomb attack caused a surrender. Fighter-bomber pilots, after strafing motor vehicles and horse-drawn carts, sometimes saw white flags raised. On August 17, 1944, the U.S. Third Army requested the Germans occupying the St. Malo Citadel to surrender. To help the Germans see the picture more clearly, a squadron of P-47s carrying 500-pound bombs slung under their wings were orbiting the target, waiting for the Germans' response. After 35 minutes, the P-47s were informed the Germans will surrender, and the planes departed without dropping their 500-pound persuaders. This is the image that pops up when Google searching St. Malo Citadel. German General Kesselring relayed in his post-war interrogation that dive bombing, terror attacks on civilians combined with heavy bombing, was Germany's undoing. This German intelligence officer indicated the single greatest cause of Germany's collapse was the destruction of its transportation system. Cutting rail lines was significant in stopping the flow of production. This caused a coal shortage in the fall of 1944. Because of this coal shortage, 50% of Germany's factory production was shut down. This page lists German road travel restrictions imposed due to the threat of fighter-bomber attacks from POW testimony. They traveled on side roads exclusively to avoid plane detection. The vehicle trail distances varied between 100 and 200 yards. Travel was limited to nighttime where the threat of fighter-bomber attack was less. The routes taken needed to be scouted prior to night travel. Vehicle convoy air lookouts were posted to scan the skies for fighter bombers. If the convoy had been spotted by a fighter bomber, the vehicles are to move to the side of the road. But the attacks occurred so quickly, the convoy crews just scattered. At 6:30 a.m., the convoys started camouflaging their vehicles and waited until 9 p.m. to start traveling again. The use of 500-pound general-purpose bombs will cause large craters in the roads which impeded Allied traffic. It is recommended that targets on roads be attacked with only rockets and machine guns. The target will sustain damage, but the roads will not be damaged. These road craters cause progressing Allied traffic bottlenecks. I hope you have enjoyed this P-47 dive bomber deep dive review and found it informative and interesting. Please consider helping out the channel by commenting, liking, and or subscribing to the channel World War II U.S. Bombers.